So let's consider a second example. This is a dot b dot c plus a dot d whole bar. So let me take the red color off, and we can simplify it a bit by taking a common. So we say bc plus d whole bar. So this is our function that we want to implement and then lay it out. So the first thing is to draw the CMOS circuit, and let me draw it here. So we have B and C in series. So B and C are in series, and these two, they are in a parallel combination with D, and the whole thing is in series with A, and we take our output from A. So this is our Nmos network. The next is our Pmos network, which is the opposite. So we start by drawing the B and C, which are in parallel, and then D, which is in series, with the whole combination. And this whole thing, you see, A is in parallel with this whole thing. So this is our Pmos network. Okay, now the next thing we want to draw is our layout, and for layout we start by using different colors. So we first draw our ground line, so I just say G, and then we draw our VCC line, which let's say we call V. Then we change the color, and this is our N-type region, and similarly we draw our P-type region. The P-type region is inside a well, which I draw in this black color, and then I use this red color for drawing the polysilicon lines. So how many polysilicon lines? We have 4 polysilicon lines. So I draw the first one, I draw the second one, I draw the third one, I draw the fourth one. Now here comes the question: which one is A, which one is B, which is C, and which is D? This will be determined by the Euler path. Okay, Euler path. So let's draw the Euler path. In order to draw the Euler path, we need to label the nodes. So we have this node V. Okay, we have this node V, and then we have this other node which is Y. Okay, so this is our Y node, and this, let's call this our one node. Okay, so let's first handle the case of Pmos. So we have to draw the Euler. We have to draw the Euler diagram or graph. We start with V, then we have 1, then we have Y. So what will happen, between V and Y, I have A. Between 1 and V, I have B, and I also have C. Between 1 and Y, I have D. So this is the Euler path for Pmos. Now let's do the same for our Nmos. So we have Y, then we have this point. Okay, call this point 2. We have this point, call this point ground, and we have this point, call this point 3. So let's draw the Euler graph again for, so this is for Pmos, and this is for Nmos. We start with Y at the top, then we have 2, then we have point 3, and then we have ground. So between Y and 2 we have the transistor A. Between 2 and ground we have, on one side we have the transistor D, and on the between 2 and 3 we have transistor B, and we also have transistor C. Now we have to define the order of variables. So let's say change the color. What about, let's say, the order A, B, C, D. Okay, so let's check with Pmos. I start with A. Okay, then I go to B. Okay, then I go to C, and you see that it fails. It fails because in order to come to D, I have to repeat either A or B. So this one does not work. Okay, so this cannot be a path. So let's check another one, and for example let me check D, C, B, A. So I start with D, then go through C, then come back to B, and you see here also I am stuck. I have to repeat D, so this one is not the answer. Now let me check the path AD, and CD. So let's see, this is A, D, C, B. So it is passed by the Pmos network. Let's check on the Nmos network. So we start with D, we go through C, then we start with A, then we go to B, D, from D we go to C, and from C we go to B. So you see this is passed by the Pmos network, and it is also passed by the Nmos network. So this is our order of variables. So we can write A, D, C, and B. So these are our poly lines. Now it's quite simple to draw the other things. So for example, let's say we want to start with the Nmos. Okay, so consider the transistor A. For the transistor A, on the top it is connected to Y, and on the bottom it is connected to 2. So you see, I have to keep Y on this side, okay, and 2 on this side, because D is also connected to 2, okay, and the other side of D is connected to ground. Similarly for C, one side is connected to ground, the other side is connected to 3. Similarly for B, one side is connected to 3, the other side is connected to 2. Now it's quite straightforward. I have to connect G with this cross to the ground. I have to connect both the 2 together, and I have to connect the output, which is here. So my output is here, okay, this is my output. Now let's come to the Pmos side. So again, on the Pmos side, on one side of A is V, and on the other side of A is Y. Okay, so I can say that V is here and Y is here. Why? Because the next one is D, and one end of D is connected to Y, so that's why I choose this one. Now for D, okay, for D, one end is Y and the other end is 1. Okay, the next one is C. So one end of C is connected to 1, the other end is connected to V. The next one is B. One end of B is connected to V and the other end is connected to 1. Okay, so now it's quite easy to connect so this one is connected to VCC. Similarly, this one is connected to VCC. This one and this one, they are connected here, so they are short. Okay, let me draw this on the other side. So that was, they are connected like this. Okay, and finally we have this one, which is connected to our output. So this is our output. So this is our final stick diagram. Now the next thing we want to do is we want to estimate the area of this one. So let me use, for example, this color. Okay, for the horizontal one, I can do it with the Nmos and the Pmos. Which one should I select? The one with maximum number of terminals. So on the top I have 1, 2, 3, 4, 5, and on the bottom 1, 2, 3, 4. So I should start with this one. 1, 2, 3, 4. So my W is equal to 4 plus 1. Okay, and this whole thing multiply by 8 lambda, which is 40 lambda. Okay, now let's calculate our length or height, whatever you want to call it. For this, consider that I have this one, okay, then I have this one, 2, then I have this one, so 3, then I have this one, 4, and I have this one. Okay, so 5. So 5 and 1 extra into 8 lambda. So this is 48 lambda. Okay, the output is considered one line. Okay, so we have the second example, and I hope that you understand all the details in this one. So let's stop it here for the second example.